Hey guys, it's Mr. Krieger. We're going to do another review. This time we're going to go over that question, that sample question that the AP board provided in the AP statistics. And then we're going to do a review of the reading I want you to do. There are some things in there that I think are important to go over. All right, so let's take a look at this question. Students at an agricultural station conducted a study to compare genetically modified corn with regular corn. Each of 33 plots of land was divided into two half plots. One half plot was randomly selected to be planted with the genetically modified corn, and the other half plot was planted with regular corn. The table shows summary statistics for the yields in bushels per acre and the difference in yield. So it's the genetically modified yield minus the regular yield for each plot. So you have three categories here: genetically modified mean, regular mean, the difference, okay? All right, let's take a look at this part A. Before I do, though, I want you to notice they have 5 parts, and they're all kind of testing different ideas. So they're able to basically cover 5 concepts in one question. And with the other question, which would probably even more parts to it, the one they didn't provide a question for, they'll be able to cover at least 10 different concepts. So let's take a look at this first question. Explain why the yields from one type of corn are not independent of the yields from the other type of corn. Now I prepared an answer for us, which I've sent you, but I thought we could just take a look at this. Okay. In this case, corn variety varies, but everything is controlled. This is the same as an experiment with twins, where one twin is given a treatment and the other twin is given a placebo. The subjects are paired, so we would be using a paired t-test. Subjects are not independent of each other. The only thing that's being varied is the treatment. So in essence, these two items, the genetically modified corn yield and the regular corn yield, are connected, therefore not independent. We'd be using a paired t-test in such an instance and not a two-sample test. All right, let's take a look at part B. Based on the summary statistics, would it be more likely to obtain a yield of 123 or more bushels per acre from a plot of genetically modified corn or from a plot of regular corn? Okay, it says justify your answer. So let's come back here. It would be more likely to obtain the yield of 123 or more bushels per acre from the genetically modified corn. Now, why is this? I'm going to come back to this. Take a look at the things they give you. They give you the quartiles here. Now, the median will tell you the halfway point. So for the genetically modified corn, the median is 127.5 bushels per acre. That means that half the plots make at least 127.5 bushels per acre, which means we can guarantee that at least 50% are going to have 123 bushels per acre and possibly more, because this is not even capturing plots that have between 123 and 127.5 bushels per acre. Now let's take a look at the regular corn. The median is 119.4, which means that 50% of the plots have 119.4 bushels per acre or more, which means that it's possible even less than half have 123 bushels per acre or more, because there could be some that are between 119.4 and 123, which will take away from the 50% in that upper from the median up, right? So for genetically modified corn, we know there's at least 50%. And for the regular corn, it could be less than 50% because there could be some plots that have less than 123, okay? So that's the answer for part B. Okay, let's take a look at part C. Okay, let's just take a look what we have here. Here's a box plot of the differences. So that's this third category, differences, okay? So basically they're taking the two plots, the single plot that's been split. They're taking the yield from the genetically modified corn and subtracting it from the yield of the regular corn and getting a difference. Most of those differences are positive, which means that genetically modified corn seems to be averaging higher yields than the regular corn, right? But there were some plots clearly that were where the regular corn was yielding more than the genetically modified corn, but that was a very small amount, less than, well, just about a quartile, 25%, okay? It wants you to describe this distribution of differences. So here's the distribution of differences right here. So we have a box plot to talk about. Let me come back to what I have here. Please remember, when you're making a description, you want to use socks and context. So I put this yellow to be the context. And what we're seeing is the differences in yields in bushels per acre between genetically modified corn and regular corn have a median difference of about 3 bushels per acre more for the genetically modified corn over the regular corn. So here I'm looking at this median value right here, which is about 3. I'm estimating it's about 3. Is the median difference, where there's about 3 bushels per acre more from the genetically modified corn compared to the regular corn, right? So that describes the center. That's the C part of SOC, center. Now, the range of these differences is approximately 22 bushels per acre. Remember, the range, that's going to be the spread. So the spread is the highest value minus the lowest value. So it's from about 20 to about -2, which is about a range of 22. Keep in mind, a range is not a range of values. Like, you don't say it goes from -2 to 20. The range is a single value, in this case, 22 bushels per acre. That is a description of the spread. Now, there is an unusual feature here. There's one outlier. On one plot of land, there were 20 additional bushels of corn for the genetically modified corn compared to the regular corn. So there's one outlier. And then, of course, we have to talk about the spread. The spread is, not the spread, I'm sorry, the shape. The shape of this distribution is skewed to the right, because you can see this tail is very long, so it's skewed to the right. You need to describe all 4 of those features from SOX or CUS, and you have to give the context, which means you must be talking about bushels per acre for the genetically modified corn and for the regular corn, okay? So that is part C. Let's go take a look at part D. Part D says, students conducted a hypothesis test where they made the difference between the genetically modified corn and the regular corn is 0. We always assume that there's no difference. And then the alternative is that there is a difference, but it's not directional. It's basically saying that it's a two-tailed test. We're just saying that the differences are not 0. Okay, so now they want to know one of the conditions for inference that was met is that the sample size of the differences is greater than 30. Why is this necessary to satisfy the conditions? Why do we have to have a sample size greater than 30? Well, the idea is, let's come back to our box plot. We have an outlier. One thing a t-test can't do is it can't adequately handle outliers in your data. So if you have outliers in your data, you need to look for something else in order to make sure to use a t-test. In order to assure normality, we're going to have to make sure that our sample size is large enough. Remember, at about 30, the central limit theorem kicks in, and then we can say that even though the underlying distribution is skewed, the sampling distribution will become approximately normal, and because there is an outlier here, we're going to need that in order to run the t-test. And finally, it says the test resulted in a p-value of 0.0003. Based on this p-value, what conclusion would the students make? Remember, we got to use context here. This p-value is very small. So I'm going to show you what I wrote here. I wrote, and in fact I made a little mistake here. It's actually even smaller than I wrote. It's 0.0003. With such a small p-value of 0.0003, we can reject the null hypothesis. There is clearly, we would say we're going to reject the null hypothesis in favor of the alternative hypothesis. We have very strong evidence to suggest that there is a difference in the corn yield between the genetically modified corn and the regular corn. What I did was I also mentioned in my answer that if you wanted a test to see if the genetically modified corn had greater productivity than the regular corn, you might want to do another hypothesis test where the alternative hypothesis for the difference is greater than 0. But I just added that, wasn't completely necessary. Okay, so that was the sample question that they had given. And as you notice, they actually talked about a lot of things here. They did a lot of things. They talked about independence of variables. They talked about how do you interpret like this data? How do you describe a distribution, right? They also talked about how you examine conditions and how do you interpret a p-value from a hypothesis test. So it really did cover a lot of different things, and that's what you can expect on your test, which will have 2 questions. Now the next thing I wanted to do for a few minutes is I wanted to go over some of this book. You should definitely be reading this section in this book that's called Top Tips for AP Statistics. And you don't have to read this first page because the format of the exam doesn't apply for you. And you can avoid reading this second page because that's not really relevant to you either. But I did highlight some things that I thought were crucial. You should definitely read all of this with the exception of, I'll tell you which pages you don't have to read, because we didn't learn that stuff and they weren't making you responsible for it. You don't have to read page 26 and 27, but you should definitely read everything else in this section. It's going to be very beneficial to you. I highlighted some things that I thought were really important. For example, write answers that are clear, succinct, and complete. I think that speaks for itself. You should read that though. Always answer in the context of the question. I've been emphasizing that throughout the year. Give just one answer to the question. Sometimes people want to make multiple arguments, but if you give more than one solution to or explanation, they're going to mark the worst one, the one that would get a lower rating. So if they looked at both your solutions and they saw one that was a little better than the other, they're going to use the worst one. So you don't want to give 2 answers, give your best answer. Okay, when making a comparison, be sure to include consideration of both items that are being compared. Okay, so don't just talk about one thing, but talk about both. Naming is not enough for description. For example, if you are asked to describe a bias involved in the survey and your response is response bias, you've only named the bias. Now you've got to describe what that bias means. What's the implication of that kind of bias? You have to describe that, okay? Interpreting the value includes giving the value. So if you're interpreting the value of R, the coefficient of the correlation coefficient, not only do you have to explain what it is, but you have to state the value. Okay, these are all important things. Okay, next important thing. If you can't find one part of a question, if you can't do one part of a question, don't assume that you will be unable to do the rest of the question. Like we saw on the last thing, you might have to skip a part and go on to other parts, but you can still do a lot of the question. And if you need to answer an earlier part in order to go on to another part, and you're unable to do that part, make up a feasible answer and then work with that answer, okay? I'm going to move on. We're now on page 6. Know how to describe shapes of distributions. Remember, this is SOX or cost that we just went over. Know how to compare distributions. Having been given a comparative display, such as a back-to-back stem plot or parallel box plots, you're asked to compare the distributions. So you have to make sure that you mention both and compare their center, their spread, and their shape, okay? Know how to interpret standard deviation. I like what they say here. Here they're given a standard deviation. 2.83 inches is a typical deviation of a girl's height from the mean height of girls, okay? So they're telling you how to actually write that out in a complete sentence, and context matters. Okay, moving on to page number 8. Down here, know how to interpret the slope of a regression line. Here's a nice way of answering what the slope means. For each 1 mile per hour increase in running speed, the predicted pulse rate increases by 15.953 beats per minute. When giving the equation of a regression line, define x and y hat. Now remember, I told you in one of the videos, I wouldn't use x and y hat. I put down for y hat, predicted variable, whatever the variable is. Let's say it's GPA, predicted GPA. And x, let's say, is the hours of studying. I wouldn't write x, I'd write hours of studying. So I wouldn't even use this. I would just, in the equation, write, like they have here, predicted pulse rate, and for the variable they put speed. And we've talked about what R squared is, the coefficient of determination. I'm just saying you should go over that, just refresh your memory on it. Okay, I'm going to go on to page 11. Confounding variables. I would read this carefully so you understand what a confounding variable is and know how to explain it. Okay, these things. Oh, remember the sample size is rarely the problem. Know how to describe bias. Okay, I would go ahead and read all of these things. Page 12. Don't talk about sampling in the context of experiments. Sampling is for surveys and stuff, not for experiments. For experiments, you would talk about random assignment to the groups. Just be careful with that. Okay, page 13. If you were asked for a completely randomized design, this means that you should not include blocking. This is a completely randomized design is where everybody gets put into a pool and you everybody would go into one of the groups and you wouldn't be doing blocking in such a situation, okay? Okay, we're going to move ahead to page 16. Okay, when you're asked to describe a simulation process, be sure to give all the steps. I would carefully read this. You need to include where in the random digit table you're going to start, in what direction will you move, how many digits at a time will you use, etc. You know, you have to be very thorough when you answer questions. By the way, I'm skipping through all this as if it's not important. It's very important. It's just that I'm highlighting things that I think are super duper important and things that we might not have emphasized enough during either the review or during the class, so that's why I'm emphasizing them now. Okay, I'm going on to page 20. You can see I'm just moving through this pretty quickly. When asked to construct a confidence interval, perform all three steps. I've told you to use that word panic, where the P stands for the parameter, name the parameter that you're measuring. The A stands for the assumptions or the conditions. You have to go over the conditions, as they say over here. Make sure you check all the conditions. The N stands for name the interval. Now you might be doing a, you could look at your calculator and go to the tests and see all the different types of intervals. Name the type of interval you're using. I actually stands for writing down the interval. And the C is the conclusion in context, okay? And remember, a good conclusion will say something like this. We are 95% confident that the mean height of all women in the town is between 62.8 and 63.6, etc. You must do a complete check on the conditions. And let's take a look at page 21 here. Know how to interpret the confidence level. Not to be confused with the interpretation of the confidence interval. They're two different things. The confidence interval is the actual interval. The confidence level, you set that 95%, usually sometimes it's 90%, sometimes it's 99%. And the confidence level is not a probability. It really literally means this, and you should read this and understand it carefully. In 95% of samples, the resulting confidence interval will contain or capture the true mean height of all the women in town. So basically, it's not a probability. It's saying that if we did this confidence interval and did this different sample 100 times, 95 times, we're going to capture the true mean in the interval, and we're going to fail to capture the true mean 5 out of 100 times. Okay, going on to page 22. I would read this carefully. When performing a hypothesis test, complete 4 steps. State the hypothesis, name the test, and check the conditions. The mechanics you're probably not going to have to do, but you might have to. In that case, you're going to be dependent on the reference table. And write a conclusion with context. Okay? Here it tells you how to check the conditions. So this is very useful stuff, but I'll let you read that on your own. Here's an important tip. Never accept the null hypothesis. Either you reject the null hypothesis or you fail to reject the null hypothesis. This one, we just did a problem like this in the sample question that the AP board provided us. Know how to distinguish between a 2-sample t-test and a paired t-test. The problem that they gave us as a sample was a paired t-test. That's where you put one type of corn in one part of the plot and another type of quorum on another part of the plot, and those things are paired and being compared directly to each other. Individual things are being compared. But a two-sample t-test, we're comparing the whole mean for groups. So not individuals being matched up, not a match test, but whole means for one group compared to whole means for another group. That's a two-sample t-test, okay? So make sure you know that. We've discussed that before, but you know, now that we're getting close to the AP, we want to emphasize that. Okay, we're on page 25 now. Know precisely how to use a confidence interval to make a conclusion of a hypothesis test. Remember, if a confidence interval includes 0, that means that we would fail to reject the null hypothesis. If the confidence interval doesn't include 0, you would reject the null hypothesis. Okay, but I would read that anyway. Okay, I'm going to skip ahead. We're almost done, basically. Yes, that's it. And again, just because I went through this pretty quickly and emphasized some parts doesn't mean that it's not useful to read. I would read this carefully. I think it'll be a great review. Again, like I said, you can start with page 3, and then there were those pages that you could skip, which were pages 20, 26, and 27. Okay?